Alrighty, in this video we're going to put together our camera script. So what that's going to do is it's going to have the camera follow the player as he's moving along the game. So let's say that we have a game, which we kind of do, I guess you could say. It's a bit of a game. Let's say that we have a game, and
Yeah, we're getting there.
yeah, and it's a bunch of platforms, and some of the platforms move, and maybe there's a big pit of death right there, and then maybe there's some more platforms and stuff like that. And then we have a player somewhere, and that player might be right here. Okay, so what we want to do is we want the camera to follow the player. So let's go ahead and let's use a different color for that. Let's say the camera is right here, and we want the screen. Oh, that's so bad. That is the worst. Okay, so let's say that's our camera. We want the camera to follow the player as he's moving around. But there's a couple of important things we want to accomplish with our camera follow script. First of all, we want the camera to allow some leeway for the player. You'll see that the player here isn't exactly, let's say he's moving to the right. You'll notice that he isn't exactly in the center of the camera. We want to allow the camera to view a little bit past the player. So that's going to be one of the challenges that we'll have to deal with. Another challenge that we'll have to deal with, though, is going to be the constraints of the camera. Let's say the world that we're building is really only this big, right? So the world is really only that big, and that's a really small world, but let's fill in it some more with some things like that, and some hills and some other hills, and let's make that go all the way down to the bottom, that go. Okay, so that's our entire level that we're looking at, and then we have our camera, which is the green, and then we have our player, which is the white. So the two big things that we want to accomplish, well, the three big things that we want to accomplish with our camera controller is A, we want it to follow the player, right? So the player gets followed. Second, we want a margin. See, that margin, that's the margin that we want the player to have with the camera. We want to give them some leeway into seeing a little bit in front of or a little bit behind the player, depending on if he's moving right or left. In addition, we also want the camera to stay within the bounds of the level. So we have a max up here and a min down here, and we want to make sure that the camera is always within those max and mins. Okay, so let's talk a little bit about the math required in order to clamp the camera into this blue box. So I want to clamp the green box and the blue box. The following the player bit, the adding the margin bit, that's all really straightforward stuff. That's just lerping to the player's position and throwing in some smoothing and tossing in a margin. Pretty straightforward. The most complex part about this is, surprisingly, keeping it within that box. All right, so let's go ahead and choose a different color to mark up some attributes or some properties of the camera that we have. And I'll remove this margin, because again, we're not talking about margin anymore. We don't really care. All we want to do is discuss how exactly we can get this green box constrained within this blue box. All right, so we talked a little bit about the orthographic size of a camera. What is the orthographic size of a camera, of an orthographic camera? The orthographic size of a camera is this number. This is the size. What exactly is that? Well, it's how big the camera is horizontally. So if we know the camera is, let's say, so if we go and take a look at the orthographic size inside of Unity, we can click on our main camera and we can see its size right here. And we can see that while we scale it down, things get bigger. While we scale it up, things get smaller. So the orthographic size is really a relationship between half the height of the camera. So the higher this height is, the wider the camera gets. And you'll notice when I drag up the orthographic size, it also gets bigger in those other dimensions. That's because the orthographic size also works with the aspect ratio of the camera. All right, so for example, we might have a screen width of, we have a width of W, which is the width of the screen, and then we have a height of H, which is the height of the screen. Then we have the size. What we want to compute is we want to compute this value and this value. Those are the two values we want. So how do we compute them given the width of the screen, the height of the screen, and the orthographic size? Well, what we can do is we can say that half the width of the camera, so this is, let's call this X, half the width of the camera is X equals size times width divided by height. This will give us half of this size. Okay, so now we have the size and we have X. Using these two bits of information, we can clamp on, or we can create basically an inequality for both the position of the camera and relative to the position of this bounding box. So for example, to compute that inequality, we could say something like position X has to be smaller than the min X. So min X plus X. So the position X has to be bigger than that. This is really, really terrible because I wrote the left part of the inequality before I wrote the right part. And so, or the other way around. There we go. And then this also has to be bigger than the max X minus half width. So max X minus X. Remember, X is this X up here that we defined as this orthographic size multiplied by the width divided by height. So this inequality will constrain the position of this camera to anywhere from, okay, so let's say the camera is has X size. We'll only be able to go to here if this is X. So this is the closest we can get this camera over here if we express this inequality in our code, is going to be X. So as far as Y, the inequality for Y is going to be min Y plus size has to be smaller than max Y minus size. That means that the furthest up that we can bring this camera is going to be size, which is going to be this line right here is the furthest up we can bring the camera, and this line right here is the furthest to the left we can bring the camera. So assuming that these values are correct, this X and this size, that means that the camera can only move its position, which is its position is this center point, into one of these guys. So let's say this is the camera right here. This marquee select is the camera. That means it can only ever move to here or to here. It can't move, or sorry, here or to here. It can't move any further. And the reason is because X is defined as half the width. Therefore, if I make this look a little bit better, it can't get any smaller than that. There's also going to be two more lines. Like, for example, we'll only be able to get X away from the box on the right, and then we'll only ever be able to get size away, so assuming this is size, from the bottom. So effectively, what we're doing is we're constructing this little border around our level and only allowing our camera to ever have a position that is at most a point on one of these two lines, or one of these four lines. So at most, the camera can only be here, or here, or here. It wouldn't be able to be down here, because if it was down there, it would look something like this, and we would see more of the level that or parts of the level that we don't want to see. So obviously this is out. Does any of this make sense? I don't know if I'm explaining this correctly at all.
Yeah, sure you are.
That sounded almost sarcastic.
Well, I have a naturally sarcastic tone, I will admit. But no, it explains how the locks of the camera can't get outside of your actual game.
All right. So it's pretty straightforward code, or it's a pretty straightforward algorithm. Perhaps one thing that might be a little confusing about this particular diagram is nothing is to scale. Realize that nothing is like this x, even though this x is actually the same value as this x, graphically, it kind of looks smaller. I probably should have drawn things to scale. But the point is that the camera can never get further away or be on a position anywhere outside of these four lines. And that's exactly what we do when we express this inequality, and this inequality can be expressed using mathf.clamp. All right, so that's basically all the math behind the camera that we need. Like I said, dealing with the margin and dealing with the following is pretty straightforward. It's really only clamping it to a level. There's a couple questions we need to ask though, or one in particular, is how are we going to define this bounding box? Well, what I'm going to do is I'm going to create a box collider 2D that will allow me to place a bounding box into the world. Then I'm going to disable that box from colliding with anything. So I'm basically only using that box collider 2D as a marker, just like what we did with our points for our follow path script. So I'll show you guys how to do that too, because you can actually selectively have things ignore physics or collision detection. Alrighty, so let's go ahead and do that. The first thing I want to do is create the bounding box for our camera. So to do that, I'm going to say game object, I'm going to create empty, and I'm going to call it camera bounds. And I'm going to move it over here. It doesn't matter, well, it does matter where it is, because what I'm going to do is I'm going to add a box collider 2D to it. And then I'm just going to make it really big. So this is the extent of our levels, or the extent of our level, or at least how far we will ever allow the camera to show something visible for. I'm also going to remove this weird little thing over here. Just delete it. Okay, so we have our camera bounds, and let's place him right there. I think it's tall enough, that should be fine. And then I'll make it a little bit wider because I'm sure we'll be adding more stuff to go in there. Let's move it a little bit to the right so that at no point can we see behind the level. So we never want to see that ugly cornflower blue color that Unity likes to put behind our level. As you see right now, when we're in the game screen, we can still see that, but that's because the camera will be automatically moved the second we start the game. Okay, so that's our camera bounds, but what I really want to do is I want the box collider to not really affect anything. So there's a couple solutions for this. I could disable the box collider entirely, or I could use this up as an opportunity to show you guys a cool feature of Unity Physics, where what we can do is we can create a new layer. So I'm going to come up to Layers, and I'm going to say Add Layer. And on Layer 9, I'm going to call this, what am I going to call it? Uncollidable, not collidable, ignore. I'm just going to call it ignore. And the ignore layer will be ignored by all physics. But not yet. First of all, let's go back to camera bounds. Let's set its layer to ignore, first of all, so that our layer is on ignore, so it won't trigger any collisions with anything. But it won't do that quite yet, because what we have to do is go up to Edit, Project Settings, and Physics 2D. Now, if we go up to this Physics 2D window, we'll see this cool little matrix right here. And this little matrix defines what can collide with what layers can collide with what layers. So what I'm going to say is I'm going to say, see this ignore right here? It's kind of sideways, kind of difficult to read, but that's our ignore layer right there. What I'm going to do is I'm going to uncheck it for everything. And what that means is now nothing will collide with this object. Although it really doesn't make too much of a difference because there's no behavior on the object in the first place. It's just kind of a floating collider that I use as a bounding box. I'm just going to ignore it anyway. In addition, we could probably write a custom game object to accomplish this with custom gizmo handles and all of that fun stuff, but we'll leave that for a later exercise or something you guys can play around with. But now that we have that done, let's go ahead and start working on our camera script. So let's save out our scene. Let's come up here to our project window, open up our code folder, and go ahead and add a new C# script. And I'm going to call this, I don't know, camera controller. And this camera controller will be responsible for doing the three things that we want it to do. A, follow the player. B, support a margin. And C, never allow the player to see outside of the bounds that we defined. So now that we've done that, let's jump back into Visual Studio, hit Reload All, come into our camera controller. Just like usual, we'll format the code and delete everything in it, so all we have is a class that inherits from mono behavior. And let's go ahead and write some code. First of all, let's work on our public interface. The public fields that we're going to support is going to be a transform for the player, a vector2 for the margin, a vector2 for the smoothing, a public box collider 2D bounds, and then we're going to have a private vector3 min and a private vector3 max. We can also combine margin and smoothing into one line, can't we? That would look a little nicer. And then probably break this off into that. But anyway, it doesn't change what we have here. We have a public transform player, two vector2s for margin and smoothing, our public box collider that will determine our camera bounds, and then two private variables that we'll just kind of use just to alias out some data so that our bounds don't have to repeatedly recompute themselves. Next up, I'm going to add a public boolean is following. Is following will determine if we are indeed following the player or not. All right, we have two methods to implement, start and update. Let's start off with start. All start's going to do is it's going to say min equals bounds, bounds min. Max equals bounds, bounds max. That'll give us our min and max. Our update method will say, let's just go ahead and say something like var x equals transform position y, or x. I based a lot of this code, or the smoothing and the following bits off the really neat little Unity sample project that comes with 4.3, but of course with some modifications. Then we're going to say if is following, then if mathf abs x minus player position x greater than margin x, so if they've gotten past the margin, then set x to mathf lerp between x, player position x, passing in smoothing.x times time.delta time. Then we'll say if mathf absolute y minus player position y is greater than margin y, then y equals y equals mathf lerp from y to player position y with the smoothing factor applied to our time step. Then we're going to do that that clamping that I talked about earlier. So we're going to say camera half width equals camera orthographic size times float screen width divided by screen height. So this will give us the camera height width or half width in units. So then we can say x equals math f clamp on our inequality. So I can say x passing in our min, which is going to be min.x plus camera half width, and then max x minus camera half width. So that'll constrain us on the x-axis. And then to constrain us on the y-axis, we simply say mathf.clamp on y, min.y, plus camera.orthographic size, which remember is half the height of the camera in units, max.y minus camera.orthographic size. Then let's go ahead and say transform.position equals new vector 3 xy transform position z. All right, so this pretty much sums up our camera controller. So let's go ahead and jump back into Unity. And I'm going to zoom in here a little bit. And I'm going to add some, I'm just going to add some more tiles. So we can walk forward just a little bit. Okay, and now I'm going to add the camera controller to our main camera. So I'm going to come up here, I'm going to say add component, camera controller. I'm going to set its margin. These are values that you can definitely just play around with to do what you want to do as far as the margin and the smoothing. But let's set the margin to 1 unit and 0.5 units. And then let's set the smoothing to 2 and 2. And then for our bounds, let's click and drag camera bounds onto bounds. So we now have our camera bounds represented. Let's go ahead and hit play and see what happens. First of all, you'll notice something very important. Our camera is now physically constrained to those bounds. Watch what happens when I try to move the camera. It lets me get kind of to the left, but it doesn't really affect anything. Now let's try to get the camera to follow us. So moving forward, it does absolutely nothing, which was not what I wanted it to do. Likely the reason why it did absolutely nothing is, let's see here. I think the bounds calculations are indeed correct. See how I can only have this? Oh, wow. Wow. Steve, I did it again.
What? What'd you do?
Is following. Defaults to false. I never set it to true. Therefore, it never actually followed the player. Okay, in our start method, we're going to set is following to true to default it to true. Coming back into Unity and hitting play, we have an error. The variable player, we never set the player on our camera. So to do that, we click on our camera, we scroll down here to player, and then we click and drag our player object onto our player field on our camera, and then hit play. And we definitely get some margin action on our movement. We definitely see some smoothing. We definitely see some clamping. Because as you can see, it won't go any further than to the left. So this is actually starting to feel like a real game, because all we can see right now are the actual art assets. We can't see any of the things behind the game, which is a very nice, makes the game feel a lot nicer, obviously. So yeah, so we can see our camera working exactly the way we wanted it to. With our smoothing factors, with our camera clamping, our player controller still works. Those eyes are starting to really weird me out. Yeah. What do you think, Steve?
Looks like it's working pretty good to me. I'm having a few frame rate issues, so I can't see the smoothing. But
yeah, I suppose that would be kind of difficult. At what, 10 frames a second or whatever you get?
Yeah, something like that is where it's at.
All right. Well, I think this pretty much wraps up our camera controller. I mean, there's not a whole lot left to do with it, or there's not really anything left to do with it. You know, there's ways to extend it to make it maybe a little bit more interesting, but for right now, it does everything that we'll need it to do for this game. And it does it pretty conveniently. I particularly like the practice of creating these little marker objects, like our camera bounds, because we can just click on our camera bounds and we can see the extent of our level, and we can know for certain that no matter what device, what resolution, what aspect ratio, that the player will always only see what's in that box. And that's just according to some pretty straightforward math that we can take advantage of. So yeah, I think that pretty much wraps up our camera.
I think you got it covered.
All right, guys, see you in the next video.